This is Dr. K. Venkatramana, Assistant Professor, Department of Mathematics, Vardhaman College of Engineering. In this video, we are going to discuss the topics Cauchy's mean value theorem, Taylor series, and Maclaurin series in the course of matrices and calculus. First of all, we are discussing about the Cauchy's mean value theorem. Statement of the Cauchy's mean value theorem: f is a function from closed interval ab to r, g is a function from closed interval ab to r, be such that these two functions f comma g are continuous. Continuous meaning is the value of the function is existing always in the interval a comma b. Second point is those two functions are differentiable in open interval a comma b. Third condition, g dash of c not equal to 0 for every element in the interval a comma b. If any two functions are satisfying these three conditions, then by using there existing an element c belongs to open interval a comma b such that f dash of c by g dash of c is equal f of b minus f of a by g of b minus g of a. Related problem we are discussing here, Cauchy's mean value theorem. F of x is equal to root x, g of x is equal to 1 by root x in the interval a comma b. If you are observing, these two are polynomial functions, so we know that polynomial functions are always continuous. So first point, f comma g are continuous in closed interval a comma b. Second condition is what? The derivative. So see here, f dash of x is equal to root x derivative 1 by 2 root x, g dash of x. So g dash of x derivative we want, this one can be written as x power minus 1 by 2. The formula of the derivative n into x to the power of n minus 1. So this one minus 1 by 2 into x power minus 3 by 2. This one can be written as minus 1 by 2 into x by root x. So two derivatives are existed for the functions, and that's why f comma g are differentiable in open interval a comma b. This is our second condition. And third condition, g dash of x not equal to 0, g dash of c. If you are observing here, these two values are always greater than 0, that means x value not equal to 0, and that's why the derivative is existing. So g dash of c not equal to 0 for all c belongs to open interval a comma b. So all conditions of Cauchy's mean value theorem are satisfied. So by using Cauchy's mean value theorem, there exists c belongs to open interval a comma b such that f dash of c by g dash of c is equal f of b minus f of a by g of b minus g of a. Substitute all values in this one. So here f dash of c is 1 by 2 root c by g dash of c is minus 1 by 2 into c root c is equal f of b. F of x value root x, so f of b root b minus root a by g of b 1 by root b minus 1 by root a. Simplify this one, 1 by 2 root c into minus 2c root c, root b minus root a by, take LCM here, root a minus root b by root ab. Here 2 cancel, root c cancel, minus c is equal root b minus root a by root a minus root b into root ab. Take out minus common and multiply, cancel this. So minus c is equal to minus of root a minus root b by root a minus root b into root ab. These two are getting cancelled, minus getting cancelled, c is equal to root ab. What is the meaning of Cauchy's mean value theorem? Here we need to show that their existing c belongs to open interval a comma b. Here finally what we got, c is equal to root ab, which is nothing but the geometric mean of A comma B. So geometric mean means A comma B are any two elements, then arithmetic mean, geometric mean or always lies between A and B. In that's why this one is always belongs to open interval A comma B. Therefore CMV theorem is verified. So like this we are deriving Cauchy's mean value theorem verifications. Now we are going with one more problem. Now we are going with one more problem is f of x is equal to sin x, g of x is equal to cos x in closed interval 0 comma pi by 2. We know that f of x sin x, g of x cos x both are continuous in the interval 0 comma pi by 2. So first point, f comma g are continuous in closed interval 0 comma pi by 2. Second point, derivatives, f dash of x sin x derivative cos x, g dash of x cos x derivative minus sin x. So derivatives are existed, so both functions are differentiable. F comma g are differentiable 0 comma pi by 2. Third condition, g dash of c. If you are observing this interval, open interval 0 comma pi by 2, the value not equal to 0. Because of that here closed interval, but we need to show that this one for open interval 0 comma pi by 2. Open interval means endpoints are not including in that. So g dash of c not equal to 0 for all c belongs to open interval 0 comma pi by 2. By CMV there exists c belongs to open interval 0 comma pi by 2 such that f dash of c by g dash of c is equal, here b value pi by 2, f of pi by 2 minus f of 0 by g of pi by 2 minus g of 0. Now f dash of c. So here f dash of x cos x, f dash of c cos c by g dash of c minus sin c, f of pi by 2. F of x value is, here f of x is sin x, so f of pi by 2 means sin pi by 2 minus sin 0 by cos pi by 2 minus cos 0. Simplify this one, we are getting cos by sin is minus cot c is equal sin 91 sin 0 0 cos 90 0 cos 0 1. So here minus cot c is equal to minus 1, minus minus getting cancelled, cot c is equal to 1. When cot becomes 1, pi by 4. So c is equal to pi by 4, which belongs to open interval 0 comma pi by 2. Like this we are verifying the Cauchy's mean value theorem. The series expansion of the function f of x is equal f of a plus x minus a by 1 factorial into f dash of a plus x minus a whole square by 2 factorial into f double dash of a plus x minus a whole cube by 3 factorial into f triple dash of a plus and so on. This one is called Taylor series. Is called Taylor series about x is equal to a. And another name of this one is Taylor series about Taylor series in powers of, another name is Taylor series in powers of x minus a. Now we are going to discuss about the Maclaurin series. Maclaurin series is existing from the Taylor series by replacing the value of a as 0. Now f of x Maclaurin series is simply replace a value as 0, f of 0 plus x by 1 factorial into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus x cube by 3 factorial into f triple dash of 0 plus and so on is called Maclaurin series. Maclaurin series or Taylor series about x is equal to 0. These are the two names of the Maclaurin series. Now we are going with the problems regarding Taylor series and Maclaurin series. Now we are going to discuss the Taylor series of the function f of x is equal to sin x. So for that, first calculate the derivatives of the given function. F of x sin x, derivative f dash of x, cos x. Next derivative f double dash minus sin x. Next derivative f triple dash minus cos x. Substitute the value of x pi by 2 in this one. F of pi by 2 sin 90 1. F dash of pi by 2 cos 90 0. F double dash of pi by 2 minus sin 90 minus 1. F triple dash of pi by 2 minus cos 90 0. Now we are writing the Taylor series formula. F of x is equal Taylor series formula f of a plus x minus a by 1 factorial into f dash of a plus x minus a whole square by 2 factorial f double dash of a plus x minus a whole cube by 3 factorial f triple dash of a plus and so on. Here I calculated only 3 derivatives, and that's why I written the formula up to third derivative. Now a, here we are expanding the Taylor series about pi by 2. So this is the value of a. Replace a value as pi by 2 in this formula. F of pi by 2 plus x minus pi by 2 by 1 factorial into f dash of pi by 2 plus x minus pi by 2 whole square by 2 factorial f double dash of pi by 2 plus x minus pi by 2 whole cube by 3 factorial f triple dash of pi by 2 plus and so on. Substitute these are all values in that formula. F of pi by 2 value 1 plus x minus pi by 2 by 1 factorial f dash of pi by 2 0 plus x minus pi by 2 whole square by 2 factorial f double dash of pi by 2 minus 1 plus x minus pi by 2 whole cube by 3 factorial f triple dash of pi by 2 value 0 plus and so on. Which one is equal to 0 and anything 0, 0 and anything 0. So remaining 1 plus into minus minus x minus pi by 2 whole square by 2 factorial plus and so on. Like this we are calculating the Taylor series of the function, given function sin x. Now we are going with one more problem. F of x is equal to e power x, about x is equal to 2. First calculate the derivatives of the function. F dash of x e power x, again derivative e power x, again derivative e power x. Always we are getting the same derivative for the exponential. Now here about x is equal to 2 means this is the value of a. Substitute x value as 2, e square f dash of 2, e square f double dash of 2, e square f triple dash of 2, e square. Substitute these are all values in the formula. What is the Taylor series formula? Taylor series of f of x is equal f of a plus x minus a by 1 factorial into f dash of a plus x minus a whole square by 2 factorial into f double dash of a plus x minus a whole cube by 3 factorial into f triple dash of a plus and so on. A value is what? 2. Substitute a value 2. F of 2 plus x minus 2 by 1 factorial into f dash of 2 plus x minus 2 whole square by 2 factorial f double dash of 2 plus x minus 2 whole cube by 3 factorial f triple dash of 2 plus and so on. Already we have the values of f of 2, f dash of 2, f double dash, f triple dash. Substitute these are all values in the formula. Then this formula changes as f of 2 value e square plus x minus 2 by 1 factorial into this one is also e square plus x minus 2 whole square by 2 factorial, f double dash is also e square plus x minus 2 whole cube by 3 factorial, f triple dash of 2 e square plus and so on. If we are observing each and every term, e square is the common, take out that one. 1 plus x minus 2 by 1 factorial plus x minus 2 whole square by 2 factorial plus x minus 2 whole cube by 3 factorial plus and so on. So this is the Taylor series expansion of the e power x about x is equal to. Now we are going to discuss about the Maclaurin series problem. F of x is equal to log of 1 plus x about x is equal to 0. Already I said that about x is equal to 0 and Maclaurin series both are same. So this is another name is Maclaurin series. Maclaurin series. Now evaluate the derivatives of the function f dash of x. Log x derivative 1 by x, again derivative 1. Second derivative f double dash of x, it is of the form 1 by x. 1 by x derivative is minus 1 by x square. Third derivative f triple dash of x is equal, it is of the form 1 by x square. 1 by x square derivative minus 2 by x cube. So minus of minus plus 2 by 1 plus x whole cube. This is the formula of the derivative of the f double dash. Now writing the Maclaurin series formula. Before writing the Maclaurin series, replacing x as 0 in this one. Then this one is x as 0 means replace x as 0 for Maclaurin series. F of 0 is equal log of 1 plus 0. Log 1 is 0. Next f double dash of 0. 1 by 1 plus 0 value 1. This is f dash of 0. This is f double dash of 0. Minus 1 by 1 value minus 1. Next one f triple dash of 0. 2 by 1 value 2. Now we are writing the formula of the Maclaurin series. So Maclaurin series formula f of x is equal f of 0 plus x by 1 factorial into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus x cube by 3 factorial into f triple dash of 0 plus and so on. Substitute the values of f of 0, f dash of 0, f double dash of 0, f triple dash of 0. F of 0 0 plus x by 1 factorial, f dash of 0 1 plus x square by 2 factorial, f double dash of 0 value is 1, f double dash of 0 value is minus 1 plus x cube by 3 factorial, f triple dash of 0 value 2 plus and so on. This one is equal x minus x square by 2 factorial plus x cube by 3 factorial can be written as 3 2s are 6, 2 3 times getting cancelled, x cube by 3 and so on. This is f of x. What is f of x? Log of 1 plus x. So this is the formula for logarithm of 1 plus x. Thank you.